Good evening, girls. Today we are going to see the third unit in our paper operating system regarding the memory management. We know that what is an operating system? In an operating system software can perform the three main managements: process management, memory management and file management. What is the process management? Process management helps the operating system to create and delete the processor. Memory management module perform the task of allocation and deallocation. File management, it manages all the file related activities, that is storage, retrieval, naming, sharing and production of files. Now we are going to see the memory management. It's very important. Memory management module perform the task of allocation and deallocation of the memory space to our programs in need of these resources. This is the classification of the memory management scheme. Actually, we are having two types. Main two types are real memory management, virtual memory management. In real memory management, we are having contiguous memory management scheme, non-contiguous memory management. In contiguous memory management, we are having single contiguous and multiple partition. In non-contiguous memory management, we are having paging and segmentation. In multiple partition, we are having fixed partition and variable partition. This is the classification of memory management scheme. It is also very important. See, in contiguous memory management, we are having fixed size partition scheme, variable size partition scheme. Now we are going to see the example program for fixed size partition scheme. In another way, non-contiguous memory allocation, we are having paging segmentation. What are the allocation strategies for fixed memory partitioning is first fit method, best fit method, worst fit method, next fit method. With this operating system problem, we can see how these algorithms are working. So algorithms are first fit algorithm, best fit algorithm and worst fit algorithm. Okay. See this problem. We are having 5 memory partitions: 100, 500 size, 200, 300 and 600. So we have to place our process of size 212, 417, 112 and 426. So we are going to see this first fit, best fit and worst fit. First fit we are going to take. What is first fit? Allocate the first free block that is large enough for the new process. See here, this example, we are taking the first process, process 1. See here the first partition. So in 100 it is not possible. So 212 it is going to place in 500 KB, right? Puriyudungla? Okay. See the first process 212 KB is going to place in second partition. And next 417 it is not possible to store next one. 200 it is not possible, 300 it is not possible. So the 470 is going to store in the last one, that is fifth partition 600K. Okay, that's all. In second round we can see this 112 KB. See this 112 which is not possible to store here. So we will see the next one. Here we are having the remaining, because we are going to store 212, the remaining we are having 218. So in the remaining place the new partition 112 is going to place. Okay. And next one is 426. It is not possible to store, it has to wait. In this way we are going to place our processor within these partitions in the first fit. Hope you can follow this. See here 212 first partition 500. In 417 is in 600. See 112 is a new partition, that is 500 minus 212, 288. The 426 no way must wait. So this is the process of storing our process in the first fit method. Hope you can understand, students. Next we are going to see the best fit. From the name itself you can identify it is the best one. Allocate the smallest block among those that are large enough for new process. In this method, OS has to search the entire list, or it can keep it stored and stop when it hits an entry which has a size larger than the size of new process. This algorithm produces the smallest leftover block. However, it requires more time for searching all the list or sorting it. That is a drawback. Now we are going to see this best fit 212. Nearest we are going to see 100 is not enough. Nearest one is 300. So 212 is going to store in 300. Nearest one. Next 417. The nearest one is 500 KB. See 470 in 500 KB. Nearest one. Next 112. 112. The nearest is 200. Last one 426. The nearest is 600. So all the four processes going to store. Here the wastage is less one. That's why it is called the best fit method. But the drawback is it will take more time. Hope you can follow this. Once again I am repeating. See the nearest one 212. Nearest is 300. This fourth one 417. Nearest is 500. 112. Nearest is 200. And 426 600 they are going to store. This is the methodology, but it requires more time for searching all the list. That is the drawback. The last one is the worst fit. From the name itself we can identify it is an allocate the large block among those that are large enough for new process. Again a search of entire list or sorting it is needed. This algorithm produces the largest leftover block, that is the wastage. See here. First we are going to take this 212. The largest is 600 KB. So 212 is going to stay in largest 600. Next 417. Next nearest is 500. 417 is going to store in 500. Third one is 112. 112 we are going to store in 388. Okay, so it is not possible to store 426, must wait. It is a drawback. We are having wastage of memory here. That's why it is called as worst fit. So when we are analyzing this three algorithm, first fit, best fit and worst fit, the best fit is always giving the best solution. Okay, hope you can following the process of this fixed partition allocation strategies with our example. First fit algorithm, best fit algorithm, worst fit algorithm. First fit algorithm is we are going to check one by one from the beginning and we are going to allocate. The worst fit is we are going to take the largest, the big one. So from there we are going to, in descending order we are going to store. And best fit is we are going to take the nearest. So here there is a wastage is very minimum. Anyway, the best fit algorithm is always best one for this methodology. Thank you students. Hope you can follow this. Thank you.